morning to you all. I hope you're doing well this morning. All right, so it's good to be out of bed, right? And without some rain, but anyway. Okay, let's take a look at a few things here. I just want to let you guys know. No, you're not calculus yet, but you will be. If I go to like the assignment portion here, you guys can see this. I have here on my website, if you guys know, remember, you want to go to this is the link, right? And then you got the titles, okay? And I think I'm going to edit this a bit since we're here. And let me do a little bit of editing right in front of you. I got some redundancy. I want to remove that. And, oops. Is there an undo? There isn't an undo. See, it's hard to see this for me on this side here. So I'll do this here, I think. Yeah. Cut. Paste. And I'm going to cut this here because I want to do it in order so that you guys can see what's going on in order here. Okay, because some of this stuff, again, is what we call supplementary. I know there's a supplementary lab, but what we've been doing is a lot of supplementary, okay, to get you guys kind of up to speed here for the most part. And again, if you want to watch some of these others, you certainly can. But let's go to some more, I should say, review. If you guys remember, we got some trig ratios, right? We started to talk about this last time. Okay, so, all right, trig ratios. Let's find out where we're at. Okay. So remember, there's really about 6 trig ratios when you're talking about a right triangle, right? And we started to mention this last time. We got what? Sine of theta. Remember I said you guys want to memorize this. What's sine always? Sine is going to be what? Sine of an angle, that ratio, because a ratio is a fraction. What's sine? Do you guys remember? Opposite over hypotenuse. And cosine, what's cosine? Adjacent over what? Hypotenuse. Good. What is tangent? Opposite over what? Adjacent. Okay, so we're going to start with those big 3. And a ratio, again, is a fraction. And then we're going to talk about the reciprocals. But let's give you guys an example, see if you guys remember this. Okay, now I'm going to draw a right triangle here. And then it's going to look like this. Here's your angle theta. Leg A, oops, leg B, leg C, or hypotenuse C, okay? How do you guys always know what the hypotenuse is? It's the length of the side opposite your what? Your 90-degree angle, okay? So we're going to go over some ideas here. So I want you guys to see this here, and what I'll start today with, maybe I'll look back here and keep it simple. And let's do something like this. I'm gonna erase this here, and I'm gonna say something. Let's just say that this length of this side is, I think I'd rather look at this. Okay, let's say this is 2. 2 here, 1 here, and let's call that A or B, right? And so let's kind of think about what this length of this side A would be, even though this is not a ratio yet. Okay, I want you guys to recall Pythagorean theorem that A squared plus 1 squared is 2 squared. And so that A squared plus 1 will be 4. A squared will be 4 minus 1, right? This is our homework we had over the weekend. And a squared is 3. So we're going to say now a is plus or minus the square root of 3. And so, ladies and gentlemen, we know that this side here is the square root of 3. Okay. Just to kind of clear out some cobwebs a little bit, some homework for the weekend, right? All right. So let's get this out of the way. And now, if I said to you, and this is what's going to happen, right? You need to know, what is sine of angle theta going to be? Okay? Sine of this angle, what would you say this is? Anybody have an idea? Well, what's the definition? You're not going to answer the question without a definition. Sine is what again? Opposite over hypotenuse. Okay, so you have sine of the angle theta is the ratio of opposite over your hypotenuse. And where's your opposite side to theta? The 1 is the opposite side. Is that true? And what's the hypotenuse? 2. So, if we say, okay, this length here is 1, that's your opposite side. Your hypotenuse here is 2. And so, ladies and gentlemen, what you want to say here is that sine will be what? 1 over what? 2. So this is what they're looking for. Okay, if you guys remember that right triangle ratio. Sine in this example is 1/2. Because it's always going to be the opposite side over the hypotenuse. Okay. Anybody have any questions on that? 1/2 here. No? Okay, so what's cosine going to be then? You say, okay, cosine theta is, by definition, the adjacent side over the what? Hypotenuse. Now, what does adjacent mean again? It means right next to. So you got this adjacent side down here, square root of 3 right next to, and then you have your hypotenuse being what? 2. So you got cosine of theta being square root of 3 over what? Over 2. Is that true? And there you go. Okay, you guys okay with that? Now you say, what about tangent? If you guys remember about tangent. Definition of tangent will be what? Opposite over what? So what's your opposite side again going to be? Well, we'll see what that is. What's the adjacent side? Let's find out what these are. And remember, we got to label this, okay? This is going to be the what? Your adjacent side. So if you know these sides, you should be just fine, right? Okay, so, all right, opposite is what? 1. Adjacent is what? Square root of 3. So tangent theta is 1 over the square root of 3. All right. Okay, ladies and gentlemen, here's the story. What you might want to consider here is you might say, okay, Mr. Judge, I got 1 over the square root of 3. What do you guys notice about that denominator? Does anybody notice anything? What do you guys remember about that denominator? I know it's a square root of 3. What do you guys remember from algebra, maybe? It's irrational, right? And so remember this idea here. The fraction you have a numerator over a what? Denominator. And in that denominator, the square root of 3 here, this is an irrational number. Okay. Now, do you guys remember, did we talk a little bit about irrational numbers? I think we did. Let me mention this here. Let's get out that TI calculator again. Let's wake it up and say if I put the second square root and you have 3 here, right? What's that second square root of 3? You guys remember, an irrational number is like when you take the square root of a non-perfect number. Okay, like it's not the square root of 4. The square root of 4 is 2. But an irrational number is a very special number, and the real definition of an irrational number is any number that has what's called a non-terminating decimal. You might say, what's a non-terminating decimal? Does anybody know? Non-terminating means it goes on forever. Yes. Yeah, non-terminating, goes on forever. And so if you look at this, you might say, well, I'm confused, and I agree with you because it ends. This is an ending, I should say decimal, but it's only ending because the calculator doesn't have enough memory to go on forever. Okay, so you have square roots are irrational numbers, really, in essence. And so, yes, in theory, this number would go on forever. But also what makes it irrational is there's no pattern to the digits. You see, a fraction, like if I said to you, we got some fractions here, like 1/2, okay? 1/2 is not irrational. So I'm going to give you the irrational number story. 1 divided by 2, this is a rational number. It's a fraction because a rational number is a decimal that terminates. Or there's another situation, right? So 1/2 terminates. They go, it's 0.5. So a rational number is one that terminates, or if there is a repeating decimal that goes on forever. Okay, that goes on forever, like this, 3, 3, 3, 3, 3, 3, 3. That goes on forever. I should say to you, what? There's a pattern here. So you got a pattern, ladies and gentlemen. Okay, 0.3333, there's a pattern. But an irrational number, which you have there, is 1.732. Now, there is a topic in algebra known as what? Do you guys remember? Because really, you always want to do what? Rationalize your what? The denominator. And in Algebra 2, there is definitely a topic known as what? Rationalizing your denominator. So I'm going to go through that topic just really quick to show you. And you might say, what does rationalizing mean? Turn the denominator into a fraction. So here's what we're going to use to do that. Ladies and gentlemen, this is the process. It's a very simple process. But I want you guys to understand the logic here. If I said to you guys, hey, is any fraction equal to itself? What would you say? Are you equal to yourself? Are you the same as yourself? Yes. So this is a true statement. You guys okay with that? Now, I'm going to do this here. I'm going to say, is it true that if I take any number, as long as it's not 0, and I divide by itself, what number is that? Isn't that 1? So isn't 1 times anything still itself? In other words, sometimes I just do this. I'll say, hey, 1 times anything is itself, and then I'll say, hey, can I write 1 as any number divided by itself where a is not 0? And so far, logically speaking, this is what? Perfectly fine. This is still equivalent, right? Okay, and then now I'm going to say this to you guys. You see that number, square root of 3? I'm going to use that number. You might say, how are you going to use it? I'm going to replace that a with what? Square root of 3 over square root of 3. Okay? Isn't that still equal? And then I'm going to ask you guys, I'm going to give you guys a little algorithm here. A over B times C over D. What do you guys know that equals? That's going to be what? A times C, B times D. And you might say, well, what is this? This is what? This is how we what? This is how we multiply fractions. And so that means we have 1 times the square root of 3 over the square root of 3 times the square root of 3. Is that right? And then that gives you the square root of 3. Oops, can't see some of these. The square root of 3 over what number? 3. And so, ladies and gentlemen, square root of 3 over 3, let me get some space here. Square root of 3 over 3. So, this fraction is also written as the square root of 3 over what? 3. And that is rationalizing your what? Denominator. Now, if you said to me, where did we ever see some of that? Well, I do have, if you want to watch some of those resources here. See what I have here? And again, I'm going to move this here. I do have some resources that you may want to watch, if I can even get in there. Gosh, look at that. You guys see what I mean? There we go. I'll put this on top. Okay, and what is there? Oh, let me go put it here. Let's go here. Algebra review. Let's click that link. And there should be something called rationalize the what? Denominator. Where are you at? Yeah. It's right here. It's also known as dividing radicals. So I have a worksheet there. And of course, next to it, see this here? Next to that worksheet is the videos for it. So I have those videos there for you on how to rationalize the denominator. All right, so there we go. I'm going to edit, copy. And where is this? Oh, let's put that in the chat. So it'll always be here. I'm going to put those in the chat for you guys. And actually, I want to put that here as well. So rationalizing the denominator. So those are things that you guys can take a look at. I did go through that process of how to do that. Okay, rationalizing the denominator. And there you go. And so now, ladies and gentlemen, you can watch those kind of things here. Now, so you do have that information. However, I'm going to give you guys the same question here now. Let's do this here. Because what I did also for all of you, copy, is this. Remember what we were doing. Didn't we approximate some of these, like the square root of 3? And let's say, if I remind you guys here, yes, you had square root of 3. If you go back to the calculator, what is this to the nearest thousands? Anybody know? What is it going to be what, 1.732? So you want to make sure you guys do that, 1.732. Okay, so what if they happen to give you now the numerical answers? Could you still find the three trig ratios? Well, how do you do that then? You're going to say what? It's the same definition. What's sine again? Opposite over what? Hypotenuse, isn't it 1/2? And what if they said, please to approximate your answers to the what? The hundredths position, for example. So if they gave you decimals now, can you, ladies and gentlemen, give the decimal representation? Right? 1/2. How do you write 1/2 now? If I clear that out, what's 1/2? 1 divided by what? 2. What does that equal? Is that 0.5? Okay. So this equals point what? 0.5. What's the definition of cosine? It's adjacent, 1.732 divided by your hypotenuse of 2. Is that what this is? Do you guys see that there? So how would you write this answer if it's as a decimal? Anybody know? How do you write that answer? In your TI or in your calculator, what would you do? Right? You're going to write this as what? 1.732 divided by 2. And what do you end up with? 0.866. What is this to the nearest, I should say what? Hundredths. 87. So ladies and gentlemen, we're going to write approximately again here, point what? 0.87. Is that true? All right, good job. Anybody have any questions on that? Maybe we should have kept that 1/2 just to be complete with all our information here, right? So this would be 1/2. Okay, what about tangent now? Tangent was opposite over the adjacent, so that's 1 divided by 1.732 now. Is that true? Did you guys see this here? So in the TI now, what would you do? You would say what? 1 divided by 1.732. And what does that give you? To the nearest hundredths. 0.58. You guys work on that approximation this weekend, hopefully. 0.58. So ladies and gentlemen, you're giving the numerical answers as well when you have what? Decimals for your right triangle. Okay, anybody have any questions on that one? What do you guys think? Easy peasy lemon squeezy? All right, good. Good, let's give you guys another example. Let's say they gave you here a right triangle now. Again, we can get that. And let's be careful. I'm writing your right triangles, ladies and gentlemen, a little different so you guys know. And you say, well, why did I do that? Because you can see right triangles differently. Okay, so you might say, well, how is it different? Well, now I have my right angle on the left. Before, I had the right angle on the right. So can you always identify the hypotenuse? Which is the hypotenuse? Angle opposite the 90-degree angle. So I would even recommend you guys do some what? Label this what? Hypotenuse. And then you have this what? Well, I don't remember the colors, but you have this side, and then you have this side over here, right? And we're going to call that, well, let's see. What's the name of this, the side in orange? What's that name? Because if you don't know the names, you can't use the ratios. It's the adjacent side. Next to, right? You might say, how do I know it's adjacent? It's always what? Next to the angle. Adjacent means next to. Now, opposite the angle is where it opens up. So that's the opposite side. So again, if we approximate these ratios to the what? We're going to approximate these to the what? To the tenths, ladies and gentlemen. What's the first one going to be? If I said to you, sine of the angle theta becomes what? What's opposite? 1. Good. What's the hypotenuse? 1.4. Good. What do we approximate to here? The tenths? Should I give you guys the colors here? 1 over what? 1.4. So what's 1 divided by 1.4? What do you guys get? 0. What? 71. Is that true? Okay, what about cosine here? What's cosine theta going to be? What's that definition? Adjacent over what? Hypotenuse. What's the adjacent side? 1. And then the hypotenuse is what? 1.4. So that's the same answer. Is that right? 0.71? All right. Easy peasy lemon squeezy? Okay. What about tangent theta? What's tangent? What's that going to be? Opposite over adjacent is 1. What's 1 divided by 1? Now, what if they said, what is this to the nearest tenths? You can put 1.0, or you could leave it as 1. But at least there's some consistency here. Is that true? You guys okay with that? So, ladies and gentlemen, this is how you find those 3 what? Trig ratios. So is it important to know your definitions? Without them, you can't what? Answer these questions, can you? Bless you. So is this still a review, clearing out the cobwebs from geometry or whatever? Okay, because trigonometry builds on this. So this is why you have to review it. So like all this time, this whole week has like been S. Anyway. All right, should we have you guys try them on your own? I want you to give me, I'm going to give you guys, I'm going to have you guys try this on your own. I'm going to call this question 1. 2.2 to 1. Question 3. We'll give it to you this way. We'll say, how about this? 4, 2, and it's not to scale, so I apologize. 4.5. We're going to want you guys to approximate to the nearest what? Hundredths now. Okay? So you're going to approximate to the hundredths, 2 decimal places. And you're going to give me the what? The 3 trig ratios. Okay, give you guys a few minutes to try this out. And let's get that calculator or that clock. Where are you, clock? Oh. All right. Okay. All right, ladies and gentlemen. Let's try this out, okay? Now, if I were you, I'd want to identify, that's 90 degrees, is that right? So the side opposite, what does opposite mean? Opens to? This is going to be your what? Hypotenuse. Good. So I know, okay, this is the hypotenuse. And then theta, we're going to say, what's the next to side? 2, the next to, the adjacent side. Okay. And then, what's the opposite side? Well, I guess that means the only one that's really left. Okay, so you're right over here. The only one that's left. This is going to be the opposite side, right? Okay. And I don't know. Okay, we'll try it that way. All right. So definition of sine again. Sine is the what? Opposite over what? Hypotenuse. We're going to approximate that. Is that right? But let me actually do it this way. What's cosine going to be? Adjacent over what? Hypotenuse. We're going to approximate that answer. So, adjacent, opposite over hypotenuse. Maybe that helps. And then what's tangent going to be? Opposite over what? Adjacent. 1 over 2. Is that right? And we know that equals 0.5, okay? Well, maybe we know, maybe we don't know. We'll see. So opposite over adjacent. We want to know those things. So let's go to the calculator and say, okay, TI, or whatever calculator you guys have, 1 divided by 2.2 to the nearest hundredths is going to be what? 0. What? 0.45. Is that right? Okay. 2 divided by 2.2 is going to be what? To the nearest hundredths. What's that one going to be? 0.91. And then you said, I don't know what 1/2 is. Well, 1/2 equals 0.5. So, ladies and gentlemen, these are all our answers that we're looking for. Do you guys agree with that? Okay, you guys okay with that first example? Is that easy peasy lemon squeezy? These are the little things you guys have to know how to do, okay? All right, now let's go to the next triangle and say, here's my 90-degree angle. Opposite is what it opens to. And then you have this adjacent side, which is next to. And then you have the what? Opposite the angle. Okay, so just identify that sometimes they'll give it to you this way as well. All right, now we're going to go through the 3 trig ratios here. Sine theta, ladies and gentlemen. You say, what is sine going to be? You guys know what sine is? And what's that going to be? 2 over 4.5. Outstanding. Opposite over what? The hypotenuse. Good. Okay. All right. Now, you guys are going to have what? Cosine. What is cosine going to be? Adjacent. 4 over what? 4.5. So you're going to have the adjacent side. Tangent is going to be what? Opposite over adjacent. So what's that going to be? Oh, we forgot to write this down. Opposite, adjacent, hypotenuse. I apologize. You guys see that? So what's opposite over adjacent going to be? 2 over 4. And we know that reduces to 1/2. Okay. We could reduce our fractions. All right, let's see what all this really becomes. We're going to approximate, see what this is to the nearest what again? Hundredths. Okay. Let's clear this out. 2 divided by 4.5, what does that give you? Is that 0.44? All right, and then 4 divided by what? 4.5. What does that give you? 0.89. Good. And then you say, I know what 2 divided by 4 is. That's equal to 1/2. It is. So what you guys are looking at, again, are all the answers, ladies and gentlemen, that we need here. And these are the what? The 3 trig ratios that they're looking for. All right. Anybody have any questions again? No? Bless you. Okay. Well, is there only 3 trig ratios? What are the others? Yeah, reciprocals, the inverses. Now, you might say, what are you talking about? I think I have them in the notes. Do we ever put them down here? Nope, not yet. Okay. So if I went back over here to the original picture, and remind you guys, there just isn't really, bless you, 3. There's really 6. And then you say, well, what are the other 3? Well, they're called reciprocals. They're known as the reciprocal ratios. So you might say, what are the reciprocal ratios? Okay, so the first reciprocal, I'm going to say, is cosecant. And then you have secant. And then you have what's called cotangent here. So really the definition of a reciprocal, remember, if you have a fraction like a over b, this is in the notes, b over a is the reciprocal, right? So we actually wrote that down. So if I flip over the fraction, you get the reciprocal now. I think I wrote it down over here. This is what we were talking about, reciprocals here. So, I don't know what colors. Gold over silver becomes silver over what? Gold. You just flip them over. And so, how we get reciprocals is really to say to you, go back and remember what the ratio for, bless you, what was the ratio for sine? You guys remember? It's opposite over what? Hypotenuse. Well, the reciprocal for cosecant, because they're reciprocals of one another, just flip that over. And you might say, well, what does that mean? It's going to be the hypotenuse over the what? Opposite side. You just flip the fraction over. So in this picture, the hypotenuse is C. So you might say, is that C over A? It is. Forgot to bring this adjacent. Okay. So it's very simply going to be C over what? Over A. So C over A, you go, okay, our color C is purple. All right. Hypotenuse. Opposite. And what do you think secant there was the reciprocal of? Do you guys remember? If you know cosine, you know secant. They're reciprocals. So you have cosine now. Well, the definition of cosine is adjacent over hypotenuse. Now, this is going to be hypotenuse over adjacent. So we get hypotenuse over what? Adjacent. So you're going to get what? C over B. Okay, you guys okay with that? What's the reciprocal of cotangent? Well, if you know tangent, you know what? Cotangent. So here, we're going to say this. Tangent is opposite over what? Adjacent. So flip it over, and you're going to say what? Adjacent over what? Opposite. So this will be adjacent. This will be B over what? A. So B is gold. A is green. Or orange and green. So there you go. So these are all reciprocals. So here's kind of what, if I go back to the original now, let's go look at this example that we have earlier. Right? I can say to you, I can tell you now, if I go back what's already known, what's the reciprocal of sine again? We want to think of it as what? Is cosecant. Okay? What's the reciprocal of cosine? That one is what? Secant. You guys okay with that? And then what's the reciprocal of tangent? You're going to remember those as well. This is going to be cotangent. Now, I can say to you guys, I know this will be 2 over 1, which is 2. Is that okay? And then what about secant now? We can say this is going to be, looks like I need space. I know, I'm going to move it all up. Okay, so now this next one. Since I know cosine, what could I do? We can say, what is secant going to be? Do you guys know? What's that going to be? 2 over what? 1.732. Is that right? Just flip the fraction over. And then, what about this over here? Cotangent, can I just flip the fraction over here too? Sure, this will be 1.732 divided by 1. Okay, so let's get these answers. What do you guys think? All right, this one is already okay. We know it's 2. We just flip the fraction over. Well, now we need 2 divided by 1.732 to the hundredths, and we need 1.732 divided by 1. I got news for you guys. I know what that is. What's that going to be? Well, let's use the calculators. Maybe you guys don't know. We'll see. So let's clear that out. And we have 2 divided by 1.732. What does that give you? Remember, if this is the nearest hundredths, what would that be? What is it? 1.1 what? 5 numerically, is that right? So this first one, 1.15. All right, what about 1.732 divided by 1? 1.732 divided by 1, what are you going to get? It's 1.732 is itself, but going to the nearest hundredths, this will give you what again? It would be 1.73. Okay. There you go. What do you guys think? Easy peasy lemon squeezy? Let's try this one here. I think, yeah, we need more space. How about if I do this? Approximate this to the tenths. And bring that down. Since we have already the 3, we just have to know what a reciprocal is. And we even have to know the reciprocal of sine. What's the reciprocal of sine, ladies and gentlemen? Let's test you on that one. You know how I used to memorize it when I was like taking trig in college here at ELAC? You know what I used to do? I used to think this way. Is the reciprocal of sine, I used to think maybe it was secant. Because it started with an S. And I used to think, oh, the reciprocal of cosine might be cosecant and started with a C. That made some sense to me. But that's not it. It's opposite. It's S and C and S and C. So the reciprocal of sine is not what? Secant, it's what? Cosecant. You guys okay with that? And then flip the fraction over. What's 1.4 divided by 1? Anything divided by itself is what? Sorry, let me rephrase that. I said it badly. Not even awake. Let's get out the algebra color purple. Anything divided by 1 is what? Itself. I apologize. Easy peasy lemon squeezy. Now, what's the reciprocal of cosine? Anybody remember that one? What's this? Secant. 1.4 divided by 1. Anything divided by itself again is what? Or anything divided by 1, I said it again, is itself. A divided by 1 is A. Any number divided by 1 is the number. 21 divided by 1 is 21. 7 divided by 1 is 7. Right? 8 divided by 1 is 8. So, okay. So those are easy peasy. And then, what's the reciprocal of tangent? That one should be easy. You know why it's easy? Because it has the name tangent in it. So it's cotangent. And you say, Mr. Judge, do I flip 1 over 1? Yes. And what's that? 1. So, ladies and gentlemen, looks like this was an easy example. There was nothing really to do here. Is that right? But moral of the story is, for this triangle, it is special, but for this triangle, yes. Yes. What's the story? For this triangle, ladies and gentlemen, I should say this to you. You got all 6 what? Trig ratios now. Okay, you got all 6. You guys okay with that? So what if they wanted you guys now, just to see if you could do this, What are the 6 trig ratios here? Can you give me the 6 trig ratios for the ones that you guys just did? Should we give you some time? We'll give you guys some time. Give me the 6 trig ratios here, and we'll test you guys on that. Let's get out our clock. Let's see what you guys can do. Okay, ladies and gentlemen. Let's see if I can. I'm going to copy this one. Let's see if we can, all the way down here, we're going to do the reciprocals for that first triangle here, okay? So let's at least see how to do this one here. Okay? All right. So sine, what's the reciprocal of sine again? Cosecant, good. Use the opposite, C versus S, C versus S. Flip the fraction over, and then you're like, oh, any number divided by itself is any number divided by 1 is itself. So 2.2 divided by 1 is 2.2. Okay, you guys okay with that one? Good, let's get out that secant here. Secant, the reciprocal of what? Cosine. So instead of 2 over 2.2, we're going to flip that fraction over. 2.2 divided by 2. Right? So you're going to say, okay, 2.2 divided by 2. Now, I don't need my calculator. That's going to be 1.1. Is that true? You said 2.2, though, divided by 2 is, in fact, 1.1. All right, good, good. Did you guys get this answer? Good. Easy peasy? Tangent is the reciprocal. Flip that fraction over. Oh, 1/2, 2 over 1. I don't need my calculator for that one. 2 divided by 1 is what? Is 2. So, ladies and gentlemen, what's that? Cotangent, good. It's cotangent, thank you. Cotangent is 2. Easy peasy. Did you guys get these? All right, let's try to see if we can sneak the last one in, right? And so we're going to write reciprocals here. Copy. And that was for the second triangle now. So let's kind of get that one in as well. All right. So what's the reciprocal of sine? Cosecant. Flip the fraction over. It's 4.5 divided by 2. Is that right? We'll see what this is approximately. What's the reciprocal of cosine now? Secant. Okay. So we're going to put secant theta is going to be 4.5 divided by 4 now, right? And the reciprocal of tangent is cotangent. 4 divided by 2. I already know that one. That's equal to 2. Okay, so the others, we're going to have to, the prior two, use our calculator. We're going to get this numerical answer here. Okay, 4.5 divided by 2, and I believe we're giving our answer to the hundredths, right? So you got 4.5 divided by 2, and that gives you 2 point what? 25, is that right? 4.5 divided by what? 4 to the hundredths is 1.1 what? Is that 1.13? Remember, we already did work on our approximation last week. Is that true? So, ladies and gentlemen, this is the remaining 3 trig ratios. If you go to your homework again, the assignment in Canvas, you know what I already put there? Trig ratios. And you say, well, where does that take me? It takes you to the trig library, supplementary material, trig ratios, and I'm going to put the answers here for you. But in this worksheet, ladies and gentlemen, I have this to the nearest thousands here. So I'll put the answers as well, just not maybe today. We'll see, maybe today, maybe tomorrow. And I want you guys to get started as soon as possible, okay? All righty. Take care, ladies and gentlemen. Stay safe. We'll see you tomorrow.